Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about tuple relational calculus. First we will give the formal definition of tuple relational calculus, then we will see some queries how to solve in an TRC or tuple relational calculus. Then what are the safety that we need to pretend on this tuple relational calculus, and lastly what is the expression of the power of languages on this one. Tuple relational calculus is in contrast with the relational algebra. The relational algebra gives us that we want to know about the procedure that the relation on to give the result. Now when we are talking about tuple relational calculus, it is in contrast to this, that it gives a non-procedural approach to the solving of problem. It gives out the relation and the records of the relation without having known the user that what are the ways to construct the relation or what are the ways to construct and fetch the details of that relation. It just put the values on the queries and then get the result out of the relation. Now we will know about the formal definition of a tuple relational calculus. As the name suggests, it generally considers all the concepts and expressions of a tuple and then gives a predicate to it so that we can check that predicate against the tuple and gets if the tuple satisfied the predicate, we will give out it as a result. So firstly we will see what is the syntax of a basic TRC or tuple relational calculus. Now the T here belongs to the tuple that we want to fetch from the relation. The P denotes with the predicate that is want to be checked against the tuple, and here the P is a function on the tuple that the tuple will be given as an input to the predicate, checked against it, and if satisfied then will be given as a result. Now as it is a calculus, so we will use the for all and there exists operator in the tuple relational calculus, and we know that its syntax like this is for all and this is for there exists in our relational calculus. So now we will construct some more formal definition on the TRC. Now we will look at the variable selection on a tuple relational calculus. So we are having that two types of the variables. One is a free variable, another is a bound variable. The free variable stands for if there is no predicate against the checking of that particular tuple. Say here T belongs to instructor. So I am mentioning that the tuple, any tuple that can belong to the instructor relation. Now I am giving an AND operator and saying that there exists some S variable from the department relation where the department name on that particular tuple T on the instructor relation matches with the department relation of that particular S variable. So now S is here considered as a bound variable rather than T, which was a free variable. So a bound variable is a variable which has some bound or condition or predicate to be checked against it. Now the TRC performs all of the operations or the calculative operations against to which tuple that should be atomic in all nature. That is, the atoms considered to be the single basic valued operations that cannot be broken further. Now when we are talking about atoms, we should consider that each of the operations to be performed on a finite set of tuples. Not there can exist an infinite set of tuples which will hamper and then degenerate the idea of being an atomic part of the TRC. So now one by one we will see that what are the atoms that we can perform on that particular TRC. Now see, the first basic type of atoms that we will use in the TRC is S belongs to R, where S is a tuple and R is a relation. Now we do not allow any type of not exist operator in this tuple relational calculus. The not exist operator doesn't exist or cannot be computed in the TRC. Now when we talk about that there exists or it belongs to R, that means we are talking about every tuple or records in the relation R where we can choose among this S freely or boundedly on some predicate. Now see, when I talk about this is a theta or comparison operator between two tuples that can belong to two different relations. So here the S and U are the tuples of some relation X and Y. So when I'm talking about having two tuples, that is comparisons between the tuples of two relations, then we are saying that we are dealing with the greater than, less than, greater than equals to, less than equals to, and not equals to operators. So now we are dealing with this 6 relational or comparison operator between two tuples in atomic way. See, often we take examples where we can check against 3 or more variables, but when the operation is being performed, it is performed on only 2 variables first, then the result is compared with the other 3 variables. So in this way, one by one we will attach the variables in our operations, but at the basic we can perform only 2 of these particular variables. Now the S and U both are tuples from the relation. Now X and Y are the relations or the domain of that particular attribute that we are checking against of that Sx and Uy. Now if X and Y doesn't belong to the same domain of attribute, then the comparison operator will return an error. Say suppose this tuple Sx and Ui is belonging to name and salary of some relation. Now the domain of name can be like Peter, John, Parker, etc. And the salary can be like 15,000, 20,000, 35,000, etc. So the name cannot be matched or checked compared to against the salary. So the domain type of the attribute that we are comparing must be same of the data type. Other than that, the comparison will have no meaning to it. Now, other than comparing it to another attribute of another tuple, we can also bring the comparison based on some constant which belongs to the domain of the attribute X. Say here S is a tuple that we have defined previously and X is the attribute that we want to compare of that particular tuple. Now we are comparing it to a variable C, or which is a constant value or a single valued variable from the domain of X. Now again we need to consider it that C should be belong to that domain of X only. Say that Sx is considering the salary of that particular instructor and C being a constructor or the constant of a particular name. So we cannot compare that John is compared to 15,000, 25,000, 35,000 and all. So the C should always belong to the domain of attribute X that we are checking of the particular tuple S. Now we need to look at this one. So the atoms that we have discussed previously all are formulas. So basically they all are predicates. Some are free variables or free predicate that there is no condition against a predicate, and some belongs to the relational comparison between two tuples on attributes. Other than that, the predicate can be a checking against a constant on the attribute of a tuple. Now it all belongs to P, that is an atom or a formula. So we need to consider that atom or these ones are always a formula or P that will be calculated on some tuple T. Now if P1 is a formula, then both P1 and not P1 are also formulas. Let us say with an example. that if we considered that salary greater than 12,000 of a particular tuple on attribute salary, then also salary not greater than 12,000 or salary less than equals to 12,000, a formula of the predicate P1, and then we can also belong it to a tuple and satisfy by the checking against that tuple. So both P1 and not P1 are also the formulas. That doesn't mean that not P1 will not affect by that particular tuple. So now look at this example now. P1 and P2 are both two predicates or formulas on some tuple T. Now, if they are both a well-formed formula, then the P1 of and P2, P1 or P2 and P1 implies P2 are also some formulas on that particular tuple T. Now, if P1 and P2 means that salary greater than 12,000 and name equals to John. Now, to signifyly say that the difference between this one and this one is, here the both predicates can deal with different types or data types of the attributes and can even of the same type of the attributes. So now we are checking against P1 is the predicate that salary greater than 12,000 and P2 is the predicate that name is equals to John. So this P1 and P2 is also a formula that we want to fetch the information, the salary greater than 12,000 and the name of the instructor whose first name is John. So we are combining these two by an AND operation. Now we can do so by the OR operation, that if there exists any instructor whose salary is greater than 12,000 or the instructor's name is John. Now this one we need to understand very properly. P1 implies P2. If there exists any P1 implies P2, then we must say that P1 is equals to not P or Q. So here P1 is equals to not P1 or P2. So first we need to calculate the P1 or P2, then make a note of it, and that will be equals to P1. If the condition satisfy, then we can say that P1 implies P2. So here the P1 and P2, P1 or P2 and P1 implies P2 will also be a formula if P1 and P2 belongs to a properly safe sequence of formula. Now for our next consideration, we should take that the T as the tuple, the S as a free tuple, R as a relation and P1 as a formula. We have defined all three of this previously. Now we should look at that what are other formulas that can be built on these conditions. Say suppose there exists a S that belongs to R. That means there exists a tuple that belongs to a relation R which satisfy the condition P1 of the S. That means the free tuple is checked against the predicate that can be a formula of that particular tuple. So now altogether it belongs to a formula. So we need to see it very clearly and minutely see the difference of having a formula and the formula built of a formula. So first we are considering a free variable. We know that the free variable is not checked against any of the predicates. Now if we check against a predicate on a tuple, then we say that the tuple becomes a bound variable. So now my P1 S is becoming a bound variable. So this bound variable that we are checking that for all S that belongs to R, and also there exists a single S that belongs to R. So if there is a free tuple, we can check a predicate against it, make it a bound variable and say that that bound variable is exist on that particular table or not. Or other than that, we can check that for all the tuple, we can perform the predicate checking and still has a resultant relation as a true value. Say for every tuple, the predicate is matched and satisfied. So the resultant relation will give us the exact same relation on the R. So in this way, we can check against the TRC of comparison operator, making a formula of other formulas, as well as we can have the combination of formulas. Now we will go to the comparison and the similarity to relational algebra. Now let's look at this in comparison to the relational algebra. P1 and P2 means generally that if both of the predicates are true, then it will give a result of true. And the P1 or P2 gives us that if any of the result or the predicate is true, then the result will be true. And if both of them are false, then only the result will be false. Now let's look at this one. Not P1 means if the P1 is true, then not P1 is false. Same goes with not P2. So if not P1 and not P2 get OR operated and the value get reversed, say for the example false or false, that is false, so we are having the not operator of false, that is true. Same goes with here, true and true, that is true. So we can see that this one is equivalent of this one. Then why do we need this one and when do we need this one? Sometimes we need to perform this one because the relation and the tuple demand so for checking against a not value, not directly the positive value. So we need to know that how is AND operation equivalently known as this not or OR operation. Now we will discuss about the there exists and for all operator. There exist means there are existing a tuple that belongs to a relation that can be of number 1 or then we have more than 1 numbers. Now for all operator defines that all the tuple that belongs to the relation supports this predicate. Now what I am saying is for all tuples that belongs to the relation R and satisfy the predicate P1 is equals to that there not exist a tuple on relation R which does not satisfy the relational predicate on tuple T. So that means all the tuple that will satisfy P1 of T, and the equivalent statement in negation is there exists no tuple of 1 that cannot satisfy P1 on T. So both are same, one is a positive one and another is a negative one. Now let's look at this query that we are using the same technique but we are selecting the tuple T that there exists some tuple S who belongs to instructor relation and the TID is equals to SID. Now let's look at this one that we are first fetching and checking against tuple S which is a bound variable and then matching that the tuple we are selecting if the attribute ID of that selected tuple is matched with the ID attribute of the tuple that we have checking a predicate against it. So if these two matches and also the salary of that particular S tuple is greater than 80,000, then only we will select tuple T. So the difference between this one and this one, which is the basic same query or the same question, that salary greater than 80,000. Now here I am using only a single tuple for checking and also selecting, and here I am making that there exists some tuple S that belongs to instructor relation as well as satisfy two conditions, that the ID attribute of a tuple S is matched with the ID attribute the tuple T and the salary of that particular S tuple is greater than the 80,000. So this will give me the same result but written into different ways. Now we will fetch some relation or result on the records of relation which will consider not a single relation but a combination of two relations. So say for example that I want to fetch the information about the department and the instructor of the department which belongs to the Watson building. So first the checking will be on the department relation that it belongs to the Watson building, and next we need to fetch from the instructor relation that which instructor belong to the department which stays on the Watson building. Now this relation is considering the instructor and the department relation. So first we are selecting the tuple T, that for there exists a is from relation instructor, that is a bound variable on an instructor relation which satisfies the predicate that the T name is equals to the S name. So let's look here that this is same more like the previous relational query, that we are checking and of the T and S joining on a predicate that if the name of the tuple relation T and name of the S relation of that particular variable are, then we can select and proceed further. Now what we are checking, that we are introducing another variable or bound variable on a tuple relational calculus, U, that belongs to the department, and then we are checking and matching against this U and S, as the department name of U should be equals to the department name of S. So S is from the instructor relation and U is from that particular department relation. So to check against that the condition matched, that the instructor from this department belongs to also the department in that particular department relation, is S or D name is equals to the D name attribute of U. And finally the predicate or the important one is that the variable U having an attribute building which has got a value Watson. So now my final resultant record in relation will be the instructor from the department on that department which lies on the Watson building. So in this way we can combine more than one relation by having more than one variable introduced and checked against some attributes or a set of attributes of that particular variable, so that the two tables can be joined or merged together. Now we will fetch some instruction to see the union operator done. So first we are selecting that some semester courses that belongs to the year fall 2019 as well as the fall 2020. So we want to fetch this information about the courses that belongs and introduced on that year. See what I have done here. I have to check more than one attributes in this one, as well as give a reunion result of 2009 and 2010. So first I am fetching that there exists a tuple T and an S variable which belongs to the section relation, where the course ID of T is equals to the course ID of S, that is a matching part or checking condition, as well as the semester of S tuple is fall. Also the year of the S tuple is 2009. Now all this comes from as 2009 fall semester's course IDs. Now we will move to the next part that will consider that there exists a variable U which also belongs to the section relation, and the course ID it matches with the T's course ID. So I am joining the U and S both with the T, where S deals with 2009 information and U deals with 2010 information. So the same goes for U also, that will happen only 2010. So now here you can look that I have joined it with a union operator OR. So if there it belongs to 2009 and also 2010, so it will list it up. So why I am using OR instead of AND? If I put AND operator here, that I am saying that a course that belongs to both 2009 and 10. But now I want to fetch information of all the courses that was introduced 2009 and in 2010. So say there suppose 5 courses that were introduced in 2009 and more and new distinct 5 courses were introduced in 2010. Then all the 10 results will be given by this query. But if I change it with an AND operator, it will give a 0 result because there is no common or matching course IDs that belongs to both 29 and 2010. So we need to change this AND selection or the OR selection. So we need to rewrite it with this OR one because of this AND one. Now look at this, that I'm changing this OR with an AND operation. So now it will give me the result that belongs to both 29 and 2010 course IDs. Now I want to fetch the information on the course IDs that belongs to 29 but not belongs to 21. Now this gives the set difference operator of a normal relational algebra. So the set difference operator means that the left relation will have all the values minus or subtracting the values that belongs to the right relation. So it basically gives the set difference operator, and for this query I want the result that all the courses that belongs to 29 but not belongs to 2010. So how can I write this operator? That I have changed this AND operator with an NOT operator with an there exists. So it belongs to that not there exists any variable that goes with the fall semester of 2010 and also belongs to the fall semester of 29. So it goes with the AND operator, not the OR one. We need to see it very carefully that the NOT operator is combined with the AND one, not the OR one, because OR gives all the results of 29 and 2010. So we cannot do it because I want first to fetch the common result and then delete it from the first result. So the common result can only be achieved using the AND operation, and the not exist operator or not operator gives us that it does not belong to the left relation, that it belongs to the right relation. So in this way we can perform the not exist operator using a combination of not and AND operator. Now we will introduce a new type of operator checking on a predicate, that is an implies operator. We have seen an example of AND and OR both. Now we will see that what happens in implies. See the simple basic message that we get from an implies relation, that if P implies Q, then for every P that is true, Q must be true. But the reverse is not always true, that if P is false, then only Q can be false. So we can just say it that if there exists any P that is true, so always there will be exist a Q that will always be true. Now we will solve a query to see an example of the implies relation that will help one predicate to imply the other one. So now we will say that we want to fetch a value or the student information that takes biology if and only if the student has registered in the course of a university. So see the implications relation on that part of the query, that if a student is belonging to the biology department, then it can be done, that is the Q predicate biology department of a student. Now the P predicate is always it belongs to, or the student belongs to the text relation, that is a student is being a part of the university. So if it belongs to a university, then only it can belong to a department, and the department here is a biology. So how to write it in the Tuple relational calculus? We will see to how. See here in this predicate, first we are checking that S tuple that belongs to the student relation and has an SID matched with the TID. Also that there exists for all U or a tuple that belongs to the course relation has got a department name biology. That means we are first checking that the student belongs to the biology course or not. Now if it belongs to biology course, then it implies that the student must belong to the university. So we will go to the next part now. See here in the next part I am taking that the student S belongs to the text relation. That means it has taken a course from the university. This ID matched with the student ID that we are selecting, and the course ID of the particular student S which has been taken in an university must match with the course ID of an U which is the biology department courses. So first we are checking that the biology department course on a student, fetching the details and check that the details of the student if only satisfied if it belongs to a university text relationship. So that we have implied the implication sign in this type of query. So see that if we do not match this part of the query, Then also the same query can be written without this part, because there is no ID if it doesn't belong to a text relationship and that matches with this courses relationship. So if a student is not belonging to the university, then it will be not generated an ID of that student. So basically this query is not a mandatory one or even a required one for this type of query. Now we'll move to the next part of our discussion, that is the safety of expression in a tuple relational calculus. So to even the issue on a tuple relational calculus, other than that we have discussed till now, is that the infinite checking relation. Let us first look at the basic relation on a tuple relational calculus. Now, if this query or an operation is given to us, so what does this operation is meaning? That there exists a tuple T which not exist with the instructor relation. So there can be an infinite number of tuples which does not belong to the instructor relation. Say there are students, there are finance department persons, administrative department persons, group D staffs. So an infinite number that even cannot go further our database system. So there are many tuples that do not belong to the instructor relation and we cannot just select that tuples. So this is an invalid format or checking in an TRC. So this type of safety that we need to mention in that TRC is that a TRC of this relation is safe considered if and only if the tuple that we are checking as a predicate of some operation does belong to only the particular relation that we are checking. So this not operation is not allowed in this part of the TRC. So if not belongs to a relation, we cannot just select that particular set of tuples. So to introduce more on this idea, we have to calculate the domain of the tuple. From that we can select a set of tuples. So the first safety issue that we need to mention and maintain in the TRC is that if there is any database system and the tuple can belong to the database system, then only we can select it. Next is the expressive power of this type of language. Now what is the expression that we have calculated till now? It is the basic relational algebra operations that we can perform even with the tuple relational calculus, but not with the aggregation and the generalized projection that we have introduced in relational algebra. So the complex and advanced features of relational algebra is not allowed in TRC, or we cannot represent it in TRC. So the expressive power of the language is equivalent to the basic relational algebra problems, including an and or not, the comparison or the relation, and checking of the matching patterns and all. So that is all for the tuple relational calculus. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.